In this section, we are going to take a look at percent composition and how we use our mole fractions to help us determine the percent of element in each compound. Calculating percent composition is very similar to calculating your percent on a test. So let's say you take a test in chemistry and you earned a total of 62 points and the test was out of 75 points. What is your percent? To solve this problem, you're going to take the points that you earned, 62, divided by the total possible points, 75, times 100 to make it a percent, and you get 82.7%. When calculating percent composition, your first step is to find the molar mass of the compound. So if we're finding the percent composition of ammonium phosphate, we want to start by finding the molar mass of ammonium phosphate. Based on the formula, I have 3 nitrogens, so I take 3 times 14, and I get 42. I have 12 hydrogens, 12 times 1 equals 12. I have 1 phosphorus, 1 times 31 equals 31. And I have 4 oxygens, 4 times 16 equals 64. When I add these up, I get a total of 149. To find my percent of nitrogen, I'm going to take 42 divided by 149 times 100, and I get 28.2%. To find my percent hydrogen, I'm going to take my 12 divided by 149 times 100, and I get 8.1%. To find my percent phosphorus, I take 31 divided by 149, and I get 21%. And to find my percent oxygen, I take 64 divided by 149 times 100, and I get 43%. We can use our percent composition to solve problems to find out how many grams of an element are present in a compound. For example, what mass of carbon is present in 85 grams of carbon dioxide? We start by finding the molar mass of carbon dioxide. There's 1 carbon, 1 times 12 equals 12, and there are 2 oxygens, 2 times 16 equals 32. When I add these together, I get a total of 44. Since I'm looking at my carbon, what I want to do is find the percent of carbon. So I'm going to take my 12 divided by 44 times 100 to make it a percent, and I'm going to get 27.3. Next, I use this to solve my problems. Basically, my percent is saying I have 27.3 grams of carbon for every 100 grams of carbon dioxide, and this becomes my conversion factor. So now to find out how many grams of carbon are in 85 grams of carbon dioxide, I take what I'm given and put it over 1. I want grams of carbon dioxide on the bottom to cancel, and based on my conversion factor, the number that goes with grams is 100. I'm going to put the rest of my conversion factor on the top of my fraction, so 27.3 grams of carbon goes on top. Grams of CO2 cancels, and to solve the problem, I take 85 times 27.3 divided by 100, and I get a total of 23.2 grams of carbon. Now try these practice problems. What is the percent composition of sodium chloride? Tell me the percent of sodium and the percent of chlorine. What is the percent composition of calcium chloride? Show me the percent of calcium and the percent of chlorine. What mass of calcium is produced from 62 grams of calcium chloride? Find the molar mass of calcium chloride and then the percent of calcium in calcium chloride. Use this conversion factor to solve your problem. Either turn in a digital copy of your notes in Schoology or turn your handwritten notes in to Mrs. Benke.